Hey guys, Mr. Dow here. Today I'm going to talk about simulating experiments and tie some loose ends up from 4.3. There's three main ways to answer any questions involving chance. Here they are. You can estimate the likelihood of a result by performing the experiment. That might take too long, might cost a lot of money, could be a bad technique. You could use probability. Problem is, you don't know probability all that well. We'll look at that next chapter. And what we're going to focus on here today is actually simulating the experiment through a number of repetitions of the experiment. For instance, if I want to know the likelihood of having two parents having a girl among their first 4 children, I'm not going to just allow the parents to keep having kids and count how many times out of 4 kids they have a girl. What I'll do is just flip a coin that'll represent having a boy or having a girl instead of heads or tails. Or I could roll a die. I could let odd digits represent having a boy, even digits represent having a girl. So that's basically simulation. Just assigning outcomes to flipping a coin, rolling a dice, picking numbers from a number generator, and so on. Let's say I'm interested in tossing a coin 10 times and finding out the likelihood of a run of at least 3 heads in a row or 3 tails in a row. Instead of just flipping the coin 10 times in a row and repeating that process hundreds of times, I can assign numbers to the outcomes of heads or tails. In this case, I'm going to let odd digits represent heads and even digit represent tails. I'm then going to go to a number generator or the random number table in the back of your book and get a list of numbers. Let's suppose I get the following sets of numbers. The first set of 10 numbers are going to represent the first trial of tossing a coin 10 times. The second number, the second trial. The third set, the third trial. I'm going to look at the numbers and notate whether a heads or tails is represented by the numbers 0 through 9. Here I've done that, and I notice in the middle of the first sequence I have the numbers 3, 9, and 5, 3 odd numbers representing 3 heads. So for the first trial, I am 1 for 1 on getting at least 3 heads or 3 tails in a row. During the second trial, the numbers 5, 7, 5 are 3 odd numbers. They represent 3 heads. And I also have 6, 2, and 8 representing 3 tails. Well, even though it happened twice, I'm only concerned with getting heads, 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 or tails, tails, tails. Out of the second trial, I'm now 2 for 2. Looking at the third set of 10 digits, I again have 3 tails and 3 heads, so I'm 3 for 3. So I could say there's a 100% chance out of 3 trials that I would get 3 heads or 3 tails in a row. If I perform this for say 25 more repetitions, or sections of 10 numbers, and let's say I just, for argument's sake, got 23 out of 25 times, I got 3 heads or 3 tails in a row. I would have an estimated probability of 0.92. Now, of course, I would need to do this thousands of times to get the actual theoretical probability, which in fact happens to be 0.826. What if it's not a 50-50 chance though, heads or tails? For instance, what if a quarterback is throwing at a completion rate of 70%? I can't let odd or even digits represent completing or not completing a pass. But what I can do is pick single digits from 0 through 9 and break that down into 2 sections, 0 through 6 being complete and 7 through 9 being incomplete. You might think, well, 0 through 6, that's only 60%. Well, don't forget 0 is a number. There are 7 numbers from 0 through 6 out of the numbers 0 through 9, thus my 70%. This would be the situation if I was rounding to the nearest tens. I would want to use single digits from 0 through 9. What if I was doing an experiment where I was not rounding to the nearest tens? For instance, if I looked at frozen yogurt sales at a nearby store, and I found that on the average 38% are chocolate sales, 42% vanilla sales, 20% strawberry sales. I cannot pick single digits 0 through 9 to represent chocolate because I cannot break down 0 through 9 in such a way that it's representing 38% of a number. I cannot use decimals. What I'm going to have to do is pick 2-digit numbers, and I'm going to use the numbers 00 to 99. I'm going to let the numbers 00 to 37 represent chocolate, Again, you see 37, you want to say that's supposed to be 38%. Don't forget, 00 is a number, so I have 38% of the numbers from 00 to 39. From 99. I'm going to let 38 to 79, because that's 42% of the numbers, represent vanilla. And 80 to 99 represent strawberry, since that is 20% of the numbers. So here's a string of 20 numbers representing the next 20 sales of frozen yogurt. I split them into groups of 5 just to make it a little bit easier on our eyes. The first 2-digit number is a 19. 19 represents chocolate. Well, I will go ahead and separate them all into 2-digit numbers, since each 2-digit number represents different frozen yogurt. I can then break that down into my classes of chocolate, strawberry, and vanilla. And out of my next 10 sales, I can see that vanilla only came up 1 time out of the 10 in this simulation. Let's look at a situation where I'm going to count random numbers until I have my first success. Maybe I want to keep having children until I have my first girl. It might take me 3 or 4 kids to do that, and I'll stop having kids once I get my first girl. So I'm going to let the numbers 0 through 4 be representing a girl, 5 through 9 be representing a boy. I'm going to look at a series of 20 digits representing children, or I guess 21 depending, and split them into until I see my first girl. The number 6 is a boy, I want to have another child. The number 9 is a boy, I want to have another child. 0 is my first success. I'm going to stop and then look at the next 2 numbers and keep going until I have another girl. 5 represents a boy, I'm going to have another child. The number 1 representing a girl, I'm going to stop. So my sequence, I had 3 children before I had a girl. In the second trial, 2 children before I had a girl. The third trial, same thing. The fourth trial, same thing. The fifth trial, I actually had 3 boys until I had my first girl. And actually, you can see on this trial, when the number 0 appeared, I had a girl right out of the gate. If you don't like looking up numbers in a number generator, you can always use a calculator. Math, over to PRB, option 5. We're selecting single digits, 0 through 9 in this case, and I would like 5 numbers in a row. If I wanted 2-digit numbers, I could type in 00 through 99 and how many digits I would want. Here are the basic steps to simulation. State your problem or describe your experiment. State your assumptions. In most cases, a head or tails or each number is equally likely to occur, and successive digits or successive flips of a coin do not influence the next, thus being independent. Assign digits to represent outcome, simulate many repetitions, and state your conclusions. That's pretty much it for simulation. The next part I want to talk about is just some loose ends from section 4.3 from your text. I'm going to highlight some of the main concepts right out of the textbook. You can follow along with the textbook if you so choose. The key points out of section 4.3 are describing the challenges of establishing causation, defining the scope of inference, and describe data ethics in design studies. Here are some key ideas on the scope of inference. What we're looking at here is observational studies don't always find a cause and effect relationship. If I'm looking for that, most likely I want to go with an experiment. Experiments don't always yield the exact results either, but at least it's more likely to find that cause and effect relationship due to a certain treatment. And a little chart where individuals randomly assigned to groups, yes or no, and how that relates to where individuals were randomly selected, yes or no, overlap each other. Here are the challenges when we have trying to establish causation. A well-designed experiment can tell us the changes in the explanatory variable, which cause changes in the response variable. We might lack some realism, can't do an experiment, here's some following guidelines for establishing causation. What about ethical issues within experiments? Some highlights on ethics. We want consent, and we want to keep everything confidential. So in summation of section 4.3, we're looking for that cause and effect relationship, most likely through experiments. We might have a lack of realism and our ethics.